The goal of this section is to familiarize you with how to solve for acceleration, speed, and time. Let's start with a few definitions. Acceleration is the change in speed per unit of time. In order to have any kind of an acceleration, a force must be applied on the object. This force causes the acceleration. As an example, if a car is just sitting on a level surface in neutral, it does not move, so it has no kind of an acceleration in any direction. If you push the car, meaning you are applying a force to the car eventually starts to slowly move. The car is now accelerating due to the force you are applying. A positive acceleration is where the force applied increases the speed. An example of this would be stepping on the gas pedal. We won't get into the details just yet, but if you are on a flat surface and you step on the gas pedal, you start to move faster. Another example would be sliding down a hill. At the top of the hill, you aren't moving, but as you start to go down the hill, the force of gravity causes you to accelerate. One last example would be firing a bullet. Initially, the bullet isn't moving. You pull the trigger, which causes an explosion, and the force of this explosion causes the bullet to shoot out of the barrel at a faster speed than when it was initially not moving. A negative acceleration or deceleration is a situation where the force being applied decreases the speed. An example of this would be if you see a stop sign ahead, you step on the brakes and you slow down to a stop. Another example of a negative acceleration would be in baseball. The player is sliding to a stop, so the force of friction between their feet and the ground is causing them to stop. In both of these examples, the force decreased the speed to 0, but we can still have a negative acceleration where we don't come to a complete stop. As an example, this might be if you are driving down the highway, but you approach a town where the speed limit is reduced, so you decrease your speed, but you don't come to a complete stop. An angular acceleration is where the force being applied causes a change in direction. An example of this would be if you are running down the hall and your friend pushes you from the side. You will probably take a couple of steps to the side to catch your balance. Here, the force your friend applies causes you to change direction. In our class, we're only going to study acceleration in a straight line. Let's look at our formula for acceleration. Acceleration is equal to the change in speed divided by the elapsed time. In other words, A equals delta S divided by t. The triangle is the Greek letter delta, which means change in. We can write the change in speed as S sub f, or final speed, minus S sub I, or initial speed. So change in speed will always be your final speed minus your initial speed. Our complete equation is A is equal to S sub f minus S sub I divided by t. Our equation circle has change in speed on top with acceleration and time on the bottom. We can also look at an equation circle with the units to help you identify what units you need for a given problem. In English units, the change in speed will be measured in feet per second. Acceleration is measured in feet per second, or feet per second squared. Time is measured in seconds. If your units do not match these units, you will need to convert your units to match. In metric units, change in speed will be measured in meters per second. Acceleration is measured in meters per second, or meters per second squared, and time is still measured in seconds. Before we look at any examples, let's talk about one more topic. In uniformly accelerated motion, the force and the acceleration are both constant, meaning they aren't changing. An example of uniformly accelerated motion would be holding the gas pedal steady on a flat road. You aren't speeding up or slowing down. If we have uniformly accelerated motion, we can find our average speed by taking the initial speed, or S sub I, plus the final speed, or S sub f, and dividing that by 2. Basically, we are just finding a normal average. One other thing to remember from our last lecture is that distance is equal to your average speed multiplied by the time. In the next video, we will look at some examples using our acceleration formulas.